Now we'll learn about the different stages of sleep. By the end of this video, you should be able to differentiate between REM and non-REM sleep, describe the differences between the three stages of non-REM sleep, and understand the role that REM and non-REM sleep play in learning and memory. So how do we measure the stages of sleep? And I bet you some of you are out there thinking, well, my smartwatch tells me. I go to bed at night, I wake up, it's on the app. Well, the smartwatch isn't giving you the whole picture. To really, truly know what stage of sleep we are in, we need to measure brain waves using an EEG. And sometimes a polysomnograph is also used. So that's a combination of an EEG and eye movement. And here we're showing you what that EEG or the polysomnograph is measuring in our brain. We'll go through each stage briefly and then focus on REM sleep. So in stage 1, sleep has just begun. And you can see the difference between being awake and stage 1, how the brain waves are slowing down. You see irregular, jagged, low voltage waves. They're mostly called theta waves. So brain activity has begun to decline, breathing is slowing down, and there's probably an occasional twitching as our muscle activity begins to slow down too. If you're a good sleeper, the stage is only going to last 5 to 10 minutes. And if you want to see when you transition from stage 1 to stage 2, hold a spoon or something in your hand outside your bed, and as you fall asleep, your hand will relax and that spoon will drop. And of course, it'll wake you up. As we move into stage 2 of sleep, overall brain activity continues to decrease, our heart rate and temperature also decrease, but it's still considered a light sleep. It's characterized by sleep spindles, which are 12 to 14 hertz waves. It's a burst that lasts about a half of a second, and they're thought to be important in memory consolidation. K complexes are sharp waves with a high amplitude wave, and they're basically associated with a temporary inhibition of neuronal firing. So again, this is a light sleep, and we spend the majority of our night in stage 2 sleep. As we move into stage 3 sleep, it's also known as slow wave sleep, and it's characterized by slow, large amplitude waves called delta waves. The heart rate slows down, our breathing slows down, our brain activity slows down, and we have highly synchronized neuronal activity. And sometimes it's distinguished into 2 stages, where stage 3 has less than 50% delta waves and stage 4 has more than 50%, but more and more often you see it just considered one stage, stage 3 sleep now. Again, also known as slow wave sleep. So again, neuronal activity is highly synchronized. There's such little activity remaining that the remaining in sources of input are synchronizing the cells. And we think that this synchronization is really important in cleaning out the brain. We have something called the lymphatic system that flushes out the brain and provides the needed nutrients, specifically during this slow wave sleep while these delta waves are activated. Now, this system is still being researched. It was just discovered around 2013. It may appear to have a role in neurodegenerative diseases such as Alzheimer's, as well as traumatic brain injury, neurodegeneration. So again, slow wave sleep is associated with an increase of growth hormone, and that's an important factor in plasticity response. So we know that athletes who put their bodies under a lot of stress and physical pressure, they spend proportionally more time in this slow wave sleep than the average person. And growing children spend more time in it than older people. Hard physical exercise typically causes a moderate rise in this slow wave sleep the next night, which all support the idea of cell restoration and repair theory. So those are the 3 stages of non-REM sleep. Now we're going to talk about REM sleep. So it's also known as paradoxical sleep. In REM sleep, REM stands for rapid eye movement sleep. So think about a person that is laying very still while they're asleep, but their eyes are twitching, their eyelids are twitching back and forth really fast. That's someone that's in REM sleep. Again, characterized by periods of rapid eye movement. The EEG waves, though, are irregular, low voltage and fast. They more resemble what it looks like when we're awake than it does when we're in a deep sleep. So that's where the paradox comes from. So during REM, the pons are sending signals to the postural muscle of the body, so they're more relaxed in the other stages, and it prevents them from moving, and that way we can't act out the dreams that we have during REM sleep. So this is just showing you what brainwaves look like awake versus when we're in REM sleep, and you can see how they are very similar, maybe a little slower during REM, but still very similar. And so again, that's the paradox there. REM sleep is when we do the majority of our dreaming, or that we can dream in other stages. So here's just a little meme about REM sleep. So just to sum up the stages of sleep, again, stages other than REM are referred to as non-REM, so NREM most of the time or sometimes. And when one falls asleep, we progress from being awake to stages 1 through 3, and then up to REM eventually. So after about an hour, we cycle through all of the stages, finally at about hour 2, getting into some REM sleep, and each sequence repeats on about a 90-minute cycle. So please note here that the earlier part of night, stage 3 dominates, while as later in the night, we're dominated by REM sleep. So I was just talking to my mom about this the other day, and she was saying how in the early parts of the night, she gets no REM sleep, and in the later parts of the night, she doesn't get any deep sleep. And of course, she's doing this all off of her Fitbit or her smartwatch. And so I was trying to explain to her, I'm like, Mom, that's how it's supposed to be. That's how it works. In the earlier parts of the night, we get that deep sleep, cleaning out our brain, using that lymphatic system. And then in the latter parts of the night, we have the REM sleep, which has other purposes. So because that REM sleep increases earlier in the later parts of the night, we tend to remember our more vivid dreams when we wake up from REM sleep. But that doesn't mean we don't dream in non-REM sleep. One reason we may remember more dreams when we're in REM sleep is because we have more REM in the morning, and that's when we're likely to wake up. But think about it. You have to try to remember that dream most of the time. If you kind of stop thinking about it, that dream memory doesn't consolidate, and that's because of the way things work in the brain. It's also important to note here, because sleep is a biological rhythm, the timing of sleep is important. So we have a window of when it's ideal for us to sleep, and that's based on everybody's own patterns and other circadian rhythms. So if you normally go to bed at 10 and wake up at 6, but one night you stay up until midnight, you're missing out on that key slow wave sleep in those first hours of the night. Your body will shorten that up and just kind of leave it out. And it's not like it pushes the whole sleep cycle back. So that's why they say it's really important to kind of try to have a schedule of when you go to bed and when you wake up, and try to keep that schedule. Now, I know it's hard for college students to do that, so it's not the end of the world to have a short period of your life where you're not getting the ideal sleep, but you don't want it to be a pattern that continues for decades.